Okay, so today we're going to be talking about a topic that's fairly difficult for most libGDX beginners. I know I had a lot of trouble when I was first starting out with it, but that's the topic of viewports. Okay, so the whole idea of a viewport, this is how things are drawn. Um, a lot of times in reading forums like Stack Overflow and stuff, they mention something called ppm or pixel per meter. This differs upon games, like different games. For example, in my game, it would be 32 pixels per meter. Sorry, I would fix this, but I don't think I can move text over in this program. So, oops, I'll do that. So basically, it's like 16 pixels per 1 meter, 32 pixels per 1 meter, and that means when you move in the game 1 meter, you move 32 pixels. It all starts with this viewport class. It has a couple children, such as a screen viewport, maybe a fit viewport. But each of these viewports have something called a camera. This camera is basically like the camera for your entire scene. For example, your camera would be basically your screen. It's what's visible on your screen. For example, if I have my camera size of this, say like maybe fit 16 by 10 or 12, how about 12? And there happens to be this guy over here. Because he's not currently on the camera, like inside the bounds of the camera, he won't be rendered. But maybe this guy would be. Okay. But another question there may be is that on your screen's measured in pixels. In libGDX, it measures your screen in pixels. For example, this would be, instead of 16, this would be 1280. And this would be 720. I'm not sure if the aspect ratios match up, but it's okay. So a big question is, how do you get 1280 pixels to get to 16 meters and 720 pixels to go to 12 meters? Well, that's where you get your pixel per meter type thing. So here, this should actually be a 9, so it's 16 by 9. But here, the pixels per meter is 80, because we have 80 pixels per 1 meter. 16 times 80 is 1280, and 9 times 80 is 720. Now, what we can do after aligning it, after getting 9 meters and 16 meters, if we say draw at like 10, 1, instead of on this isn't actually referring to pixels anymore. It's not saying 10 pixels by 1 pixel, which would be like really like down here. It's actually saying 10 meters by 1 meter, so it'd actually be somewhere like right here. The thing to note about this is that when these parameter things, these are not ints. These are not the exact positions of pixels. These would be floats. For example, or if they were to be ints, then I could only put in 9 times 16 combinations of positions, which is 144 positions. But if I make them floats, what happens is it could be like 10.3 and then 1.2. And then in order to figure out where to render on the screen, my program, this is all handled in the batch projection matrix, but my program would then take these values and multiply them by 80. So 10.3 times 80 and then 1.2 times 80, and then render those pixels. Okay, so this is the default code you're given to begin with. And that will lead to this. Oop, that's some messed up. Alright, it's just in the bottom right or bottom left hand corner, just rendered fine. But this is not using pixel per meter type things. Instead, it's drawing the this draw method from the batch uses the image's width and height. You can see it just uses the width and height of the texture. And that width and height is actually in pixels. So let's try and convert that to meters. So to start, we're going to go up here, and we're going to make a viewport. We're going to initialize the viewport. Viewport equals new. Oh, viewport is actually an abstract class. So to start, we're actually going to use screen viewport, because this guy happens to have a pretty convenient method where I can set his pixel for set units for pixels. Oh, actually I need to change this guy to a screen viewport in order to utilize those methods. Set units per pixels. So if we take a look at this this method here, it just sets an instance field here, and in the update method, when it sets the world size, it actually multiplies the screen width times the units per pixels. So if we want to change from pixels to meters with more pixels than meters, we actually have to make this units per pixel value less than 1. So if I want to do 16, have a public static float ppm equal to 16 pixels per meter, I'm actually going to have to multiply this over 1 divided by ppm. Like that. And then now each time the update method is called, it will multiply that 1 over ppm times the screen width. But as you could see from this set units per pixel method, we need to call update on it first. This would be usually handled in a game screen, but because we're not making a screen here, because this is just a simple tutorial, we'll just do it right in here. We'll do viewport.update with the width and height. We'll do gdx.graphics.getWidth, gdx.graphics.getHeight. Okay. And now we can, and now it has the width and height, so it defined the world size as the width divided by 16 and the height divided by 16. And now to actually get it in our drawing, we'll just apply the projection matrix from the viewport, like so. And now, when we run it, we should see something interesting instead of the previous result. Okay, so instead of a big image in the left, we see a zoomed up version of the image in the middle, and that's because viewports have a center at 0, 0. So we drew it at 0, 0, so it draws in the middle. This is actually negative coordinates, and this is like positive. To demonstrate it's all working, I'm going to put a -5 here, and then we can try running it again and see if the thing shifted over 5 times 16 pixels. So as you can see, that's a pretty big shift from what it was before. So I think it is working. Okay. So you may be wondering, how do I bring that image back to its proper look before I applied that viewport? And the answer is through the width. So this is actually what the that shortened version of draw is doing, as I showed before. But this returns a really big int. So when the batch is drawing it, it's using this in terms of meters and this in terms of meters. So that's why it's becoming so big. In order to fix that, we just divide by our ppm. And now that's how many meters it should be. That's why I said it must be a float beforehand, so that this value is a float. And I will get my picture just like I did before. So that's it, basically, for the tutorial. Viewports aren't actually that hard once you get into it. You should probably try and use a screen viewport. The other viewports require you to manually make the world size. But other than that, that's it. Thanks for watching. See you next time.